Welcome to the Object-Oriented UX podcast, a podcast about tackling complexity head-on, gracefully organizing massive amounts of information, and designing scalable, future-proof, and of course, naturally intuitive object-oriented user experiences. An OUXer is a powerful blend of information architect, business analyst, facilitator, and UX strategist. If this sounds like you or what you aspire to, you are so in the right place. I'm Sophia Prater, UX designer, chief evangelist of Object-Oriented UX, and your host. Let's jump into it. What's up, OUXers? Sophia here, continuing on with step 6 of the ORCA process in the ORCA series. We are getting into relationship requirements today. So if you haven't checked out the first 5 parts of the series, you can go to OUX.com/hi/ORCA series. And that link, of course, is going to be in the show notes. So in that series, the first 5 parts, you will get a really nice overview of the discovery round of the ORCA process. And then you will get into step 5 of object requirements, the beginning of the requirements round. So if you're new here, ORCA stands for objects, relationships, calls to action, and attributes. And we go through these 4 pillars of the ORCA process 4 times, sometimes more. The basic steps of the process, it is a 15-step process, which I know sounds like a lot, but this is totally remixable, totally flexible. But these steps do kind of go in an order. There's a lot more content that I have out there on mixing the steps up, mushing the steps up. But here in this part 6, we're getting into relationship requirements. So to get into relationship requirements, there's 2 things that I'm going to talk about today. So I'm going to talk about my cat saving fire department and some add-ons to my cat saving fire department. If you have no idea what my cat saving fire department is, that's okay. We're going to do a quick overview. It's nowhere near the in-depthness that we go through in the OUX masterclass. So if you do like what you hear here, then I highly recommend enrolling OUX.com/masterclass to get all the goodies on my cat saving fire department. We will go through what that is, and then we're going to talk about a few ways that I've been adding on and going into more detail. And then the other piece that I want to talk about is I want to talk a little bit more about tree systems and how to recognize tree systems. We've got over here in the OUX world, we've got a brand new rule of thumb. Thank you, Richard Gower, and also shout out to Alex Davidson, who really helped kind of solidify this very, very important rule of thumb on how to identify tree systems, which is a big struggle for folks getting into OUX and going through the masterclass. It's very common to learn about tree systems, maybe read the article that I have out there about tree systems, or even watch the videos in the masterclass and get really excited about tree systems and then start misidentifying them. So we're going to talk a little bit more about how to identify them with this really awesome, very simple trick to make sure, like, is this a tree system that I actually have on my hands? Or is this just a series of nested objects going from big to small? Okay. All right. So before I jump into my cat saving fire department and of course, tree systems, we need to talk about nested objects. So in step 2 of the ORCA process, where we hit the last time we were talking about relationships in that first round of the ORCA process, that discovery round, in this podcast, I really just talked about system modeling. I didn't get into the nested object matrix, which is such a gem of the process. You can actually learn about the nested object matrix also in our Udemy course. So that's our OUX basics course, really just the fundamentals, but you can learn about the nested object matrix there as well. And I've got quite a few videos on YouTube here and there as well about the nested object matrix. Anyway, I realized, oh my gosh, for my podcast listeners, I really need to step back and define what is a nested object. And then we'll get into my cat saving fire department, which is this really rigorous and fun process. I might have just used air quotes fun. I think it's really fun. Anyway, it's a process for analyzing your nested objects and making sure you have full understanding, making sure you don't have any blind spots with your nested objects. Also, just making sure there's not any opportunities for innovation that you're missing. So my cat saving fire department is actually a really great tool for micro innovations. A lot of things that I find out there in software that I'm using, I look at it and I'm like, they didn't do my cat saving fire department. Wish they had, really wish they had. So Okay, backing up. What is a nested object? So nested objects are basically relationships manifested. Okay, so in OUX, and you learn this in the system modeling podcast episode, relationships in OUX we really look at cardinality. Okay, so we use a lot of has-a terminology, and we describe the cardinality between two things. So because we're nearing the end of the year and I'm just now getting into the Christmas spirit and the holiday spirit, we're going to do a Santa theme. Okay. So on my examples, we're going to pretend like we are designing an app for Santa to help him manage delivering a bunch of presents. Okay. So in this app, like let's just do some quick noun foraging here. Okay. If I'm thinking about Santa delivering presents, okay, we've got gifts. All right. So there's going to be gifts. There's going to be toy designs, right? So there's like the toy design of the Jack in the Box. And then there's like the 500 million Jack in the Boxes. And there's like, little Joey's Jack in the Box, right? That has to go to this house. So we can have the actual gifts, the toy design, and this is going to come back. We're going to talk about this more when we talk about tree systems, foreshadowing. Okay, but we got the gift. We've got the toy design. We've got potentially households. So like locations or households. We got kids, right? So the kids that are getting the presents. And we probably have like sacks, like, how like Santa has all of his sacks on the back of his sleigh. He probably needs to know which sack to go into when he's stopping at a household or a location, right? And which gifts are actually in each sack, right? There's got to be some sort of organizational method. So like when Santa gets out his iPad or whatever that system is, we don't even actually need to worry. This is the beauty of the ORCA process. We don't need to worry about the implementation right now. Like, is it an iPad? Is it some VR goggles or AR goggles, right? That he's got on that he can like X-ray vision, look at the sacks and see what the gifts are inside. Doesn't matter the implementation yet. We're just figuring out, okay, what are the things in this problem domain? Okay, we named about 6 there. And then we're going to start exploring the relationships. So in a nested object matrix, I line up all those objects across the X and the Y axis, and I would explore those relationships using cardinality. So I might say a sack has 0 to many gifts inside of it, okay? You could have 0, right? Because it hasn't been filled yet, or it's completely empty, right? I could say a kid has 0 to many gifts that they're getting, right? So you're going to have some kids they're on the naughty list. They're not going to get any gifts. You could also have a household has 1 to many kids that live there, right? A household won't even be on the radar unless it has at least 1 kid inside, right? Probably would talk to my my stakeholders here about that, but I'm pretty sure that that's true, that a household is going to have 1 to many kids inside of it. Okay. So that's how we kind of describe relationships in the OUX world. And when we talk about nested objects, we're kind of talking about those relationships relative to each other. Okay. So let me explain with an example. So if I say a household has many kids that live there, or are there on Christmas night, right? It's actually, maybe they don't live there. It's like, where are they on Christmas night, which is an interesting design challenge. So a household has many kids that are there on Christmas night. A kid has only 1 household that they are at on Christmas night, right? They can't be in 2 places at once. So that's going to be a has 1 relationship. So if I'm looking at the kid, okay, the thing that is nested within the kid is that 1 household. It is nested within the kid. If I'm looking at the household, all the kids are nested within the household, right? So we talk about host objects and nested objects, all right? And it depends just kind of on which way you're looking at it, which one is the nested object. So host object and nested object are relative terms. Got it? Okay, let me give you one more example. A kid has 0 to many gifts that they are getting. All right. Then what I could also say is a gift has 1 to many kids that are getting it. Do you have gifts that are for multiple children, right? That are shared, like a trampoline, right? So that's for all 5 kids or something that are in this household. They're all getting the trampoline, right? So again, I need to talk to my stakeholders. I need to talk to Mr. Claus and see, does that make sense? Does every gift really just go to 1 child, or do we need to design this system so that the gift can go to many children? Okay, so if I'm looking again at the kid, all right, I see their nested household that they're going to be at, right? I'm also going to see the nested gifts that they're going to get. Now I'm looking at the gift. I'm going to see the nested kids that gift is earmarked for, basically. And I might even say, usually this is one, but we need to account for this also going to many. Or maybe it's the gift can be for the household. Or, maybe it's just for all the girls in the household, or it's just for the two kids that are over 10 or something like that. So hopefully that makes nested objects make sense to you. Okay, so now what I want to do with my cat saving fire department, another acronym for you. So this is the real meat of relationship requirements. So we've already mapped out all of our nested objects in Discovery with the nested object matrix. Now what we could do is we go into each of those nested objects and we analyze it by looking at the mechanics, the cardinality, sorts, filters, and dependency. Okay, that's my cat saving fire department, all right? So if I am looking at, let's go back to a household has one-to-many kids. So my nested object here is those one-to-many kids in context of the household, okay? So first I want to do, when I look at the mechanics, I want to look at how is that actually happening in our system? How is that going to work? How do we know where the kids are on Christmas night? So it might not be their home address, right? They might be staying at grandma's house, right? Or they might be on vacation somewhere. So that is where I would need to be talking to my client about this and saying, oh, how do we match households? How do we nest kids within the correct household? I should probably just say location. Let's just say location. Building, right? Let's say building, or that there's a chimney or a window that needs to be crawled through, all right? So let's use the word building. Okay, so how do we match those kids to the building? Is this just like North Pole fairy dust? Does this have to do with when they write letters in? Do we need to make sure that when they write a letter and they need to say, like, this is where I'm going to be on Christmas night, Santa? Like, does that happen? I don't know. Is this actually a big problem today where gifts are going to the wrong place because the mechanics of how these things are connecting doesn't really work? So connections can happen by a user action. It can happen by an algorithm. It can happen by artificial intelligence. It can happen by just the system. It can happen by an admin, right? So maybe it's an elf. Maybe there's like a certain department of elves that do all this manually. I probably want to know about the procedure. So that's mechanics. We explore, how does this actually happen? Do we need an interface for this? Do we have any blind spots around this? Okay, and so much good stuff comes up when you ask these questions. All right, cardinality. So we already know this is one-to-many. I'm going to explore this deeper when I get to relationship requirements, that a household has one-to-many kids. I might ask, hey, Mr. and Mrs. Claus, is there ever a reason that you're going to go to a house even though there's 0 kids there? Maybe we don't track where the kids are actually staying tonight. It's just that's their location. And they're just going to have to get the presents when they get home, right? So maybe there's no kids there right now. How is this actually working? Is it ever 0? And then when it comes to many, I might say, how many is many? That's the question that we really look at. So when we're in Discovery, we just say a blanket, like, okay, it's going to be one-to-many. Now I get into how many is many. And there's a really good reason for this. There's so many design implications that we're going to get to when we get to sorts and filters in a second. So let's say I assume, well, okay, the average number of children is, at least in the US, is like 1.8 or something like that. So let's say 2 kids. But if we're looking at this globally, of course, most houses aren't going to have more than 10 kids. Now, in discussion on this, though, Santa might say, well, actually, I deliver to children's homes. I also deliver to children's hospitals. So some of the buildings that I go to, there could be thousands of kids in that building, or hundreds. Oh, so through asking this question, a potential blind spot was surfaced to me that I was thinking, oh yeah, like if you're looking at the household, we probably only need quote unquote space for like on average, like maybe 5 kids or something like that. So we might look at like the averages and the mins and the max, and I'm going to think like, as long as I design this to hold like maximum, like, I don't know, 15 or something, then it's going to be okay. And then we have this conversation on how many is many. Well, it turns out actually a lot of these locations, these buildings will house thousands of kids. So this affects now when I go into the sorting and filtering, so now my cat saving fire department, the saving fire department, the saving fire part. So when I'm looking at the sorts and the filters, the more the many is, when I look at cardinality, the more sorting and filtering I need within the context of a household when I'm looking at all the kids in the household. Okay, so because it could be hundreds or even thousands, I definitely need probably some sort of sorting and filtering mechanism on that versus like if it was only going to be on an average 5 to 7 or something like that, you don't need as many sorting and filtering mechanisms, right? So first thing with sort, I definitely want to say a default sort. What is the default sort? So is the default sort, so I'm going to look at the metadata on the nested object. So nested object is kids. So I probably have age. What else do I have? I have age. I might have whether they're on the naughty or the nice list. What else might I have? Some sort of gender, right? So, and I will probably definitely be asking about that, right? So what are the, what are the different values that we would have for gender within this system? What else? What else can you think of? What other metadata would we have on the kids? Maybe their interests too, likely their interests as well. We might also have their current location, okay? Like we're using a little bit of like North Pole fairy dust here. So maybe we do know actually where they are in the building too. So we have them like geolocated as well. So what is the default sort? Is it by the nearest? So if Santa opens up this system and sees all the kids within this household, does it matter to be the nearest within me? Does it matter who's looking at it and what the context is? So this is Santa on site in the location, okay, versus an elf that's doing an assistant elf that's doing all the packing, right? Or matching gifts to children. Or doing kind of like the systems engineering behind how are we going to pack all the sacks, what sack needs to go to what location, how is that going to work? Okay, so that's where I would get into what is the default sort. Are there any other sorts that we need to account for, maybe even depending on role, who's looking at it? And then are there additional filters? Do we have a filter by the naughty list versus the nice list, right? Because maybe we have separate sacks. Maybe we even filter by sack, right? So we can even filter by another nested object. Okay, so maybe a kid has gifts and the gifts have a sack. Okay, so lot going on there. And then finally, dependency. So dependency is looking at if something happens to the host object, how are the nested objects affected? Okay, so something, God forbid, happens to that household. It burns down or something like that. Like what, like likely kids are still fine. Let's assume that the kids are still fine. Or that house, something terrible happens to the house, okay? So the house is offline, so to speak. What then do we need to do? So likely in this system, the kids are not deleted as well. If the house looks like, okay, this household doesn't exist anymore. Y'all, I did not script this beforehand, so I really didn't know where these examples were going. I didn't mean for it to get so morbid. I'm sorry. But that's the one example I can think of for why would a household get deleted from the system? Let's say the house burned down, everybody got out, and insurance is paying for it, okay? Christmas miracle, a better house is going to get built. Okay, so what we need to do from a design perspective is say, okay, no, the kids are not deleted. Now, there are cases where if the host object is deleted or archived, the nested objects are also deleted from the system. Okay. God, I'm going to get into more morbid examples. Let me step away from the Santa example for a while and talk about an example where they would be deleted. So that would be, let's say I've got an article, has many comments. Okay, if the article is taken down, likely the comments are taken down too. Those disappear as well. Okay, so things like that. So that is dependency. What actually happens? And I might want to design the system where, no, the children are not deleted from the system, but some alert mechanism has to happen where now we need to design what's going to, do we need to track now where those children are going to be on Christmas Eve, right? Okay. So this is the type of things that we think about with my cat saving fire department. Okay. So that's a brief overview on this analysis that we go through for all of our nested objects, or at least our most important nested objects. Okay, so I'm going to give you now 2 add-ons to my cat saving fire department, and I have not come up with a good acronym for this, but 2 other things that I found myself thinking about when I'm in relationship requirements and I'm thinking about my cat saving fire department. Another one I think of is group by. So group by is different than sorting and filtering, okay? So again, I'm looking at the house. I see all the children nested within that. I keep using different words. Shape-shifting labels, y'all. Do as I say, not as I do. Building. Let's call it a building. Okay, so I'm looking at the building and I see all the nested children, anywhere from 1 to a couple thousand. I have some sorts in place. I've got some filters in place. What is grouping? So grouping is kind of like sorting by an attribute that's really more of a filter attribute. So it's basically like you might group by status. So I might group by naughty versus nice list, okay? And instead of filtering, when I'm filtering by the naughties versus the nice list, if I filter by just show me everybody on the nice list, I'm not going to see my naughties, right? And vice versa. Group by is I still would actually see all the instances on that list, but they're going to be chunked out and grouped by that metadata, okay? Maybe in some sort of order. So if you think about also like a Kanban view is basically grouped by, okay? I'm still seeing everything, but it is grouped by a certain attribute. Often status is one that is very commonly used when we think about group by. I also might group by, like, let's say, neighborhood or something like that, or interest, right? So maybe we have the ones that their primary interest is sports versus art versus science or something like that. Maybe we have a handful of macro interests. We can maybe group by that as well, because I still see everybody, but they're grouped, all right? Which is very different than sorting, where I'm still seeing all the instances. They're just reordered by an attribute that has what I often call has a gradient to it, has a very clear high and low, top and bottom, and lots of different values in between. Okay, you don't really group by date, right? Like, let's say birthday. Birthday wouldn't make a lot of sense to group by, because likely in any given household, you're not going to have very many kids that have the same birthday, right? But you might definitely want to sort by birthday. Okay, so is that by age, or is that just by day in the year? We can talk about that, right? So if that would be valuable for my customer. All right, the other fun little add-on for my cat saving fire department is display. Okay, so we talk about this when we talk about when we get into sketching, we sketch out a bunch of lists. We do think about the display a little bit. How is that list displayed? Is it displayed on a list, as a map, as a calendar view? We can also bring this thinking into my cat saving fire department. We can bring it up into relationship requirements, and then it'll actually, it's kind of like a bottom up way of thinking, which is a lot of OUX is top down, bottom up, top down, bottom up. We can bring this back around when we get to sketching, the work that we did here in relationship requirements, where we think about how are we going to display a list of kids within the context of a house. I did it again. In the context of a building object, because it might not be a house. So is it just a list? Is it like a kind of a table view, right? Or do we want some sort of like card gallery view? Do we have multiple ways of displaying all the kids within the building? All right, do we have like a 3D map view of the household with all the kids kind of like, what is that? what is that Harry Potter map called? The Marauder's map. Is that right? Is my Harry Potter lore? Yeah, like Marauder's map style. That might be really important when Santa is on site, right? So that Santa knows where the kids are and if anybody's out of their bed. Probably really important if we could do that. So that would be a display. I'm at the house. I kind of see this X-ray. I did it again. I'm at the building. I can see this X-ray version of the building, and I can see all the kids plotted within this. Okay. So that would be thinking about the display. So I'm getting into a little bit of UI here, okay? Just starting to tap into it just a bit on what this is actually going to look like. What is this nested object, this list of nested objects, going to look like within the context of this other object? Okay, cool. So that's my quick overview of my cat saving fire department. It is a lot. It's a lot of exploration, but all of these decisions need to be made by somebody at some point. And often what happens is these decisions are made either after the fact, they're made at the 11th hour by a developer who was not given clear direction on this. So they're not really made from a user-centered perspective. And sometimes we can run into problems if we don't think about these early. So thinking about this stuff, having thinking about these questions, having these conversations early before you're even getting to your wireframes and your sketches and your designs is completely invaluable. So many good questions come up, so much good, big and little bits of innovation bubble up when you think about this. And also really helps you prioritize your nested objects later when we get to the prioritization round, because we definitely get a sense of the level of complexity of this nested object, right? Where before saying, oh, we're going to have a household, a building. I don't know why that's so hard for me right now. A building has 0 to many, 1 to many kids inside of it, right? That seems really easy. But then when I really start breaking it down, I'm like, ooh, that's going to be tough. All right, so it helps you prioritize from a development standpoint, also understanding the real value of this, like even just thinking about that display and Santa being able to get that display of all the kids within the house and where they are. Like maybe that's just super high value. We really need to prioritize that. So it's going to help with prioritization later on. Now let's talk a little bit about tree systems. So this is part 2 of this podcast. I was like, should I just do one or the other? No, we're going to give you my cat saving fire department and this new rule of thumb for tree systems, because this is so important. And I'll probably make an article on this. I did post about this in the OAUX forum. I posted in the OAUXer home base, which is masterclass only. But I'll probably write a public facing article at some point. Okay. Common thing that happens with tree systems. So tree systems, I have describe it in this article that I wrote, I don't know, a while ago, a couple months ago, maybe a year ago, Wrangling Complexity with Tree Systems. So we will have that linked. And now when I teach it within the certification program, once people get to relationship requirements, they get excited about tree systems, and lots of things that are not tree systems get tagged as tree systems. So the way that I describe tree systems is going from general to specific. And in this article, I write about all the benefits of finding your tree systems where you have objects that go from general to specific, and how this helps with permissions questions, how this helps with data trickle down and data roll up. Lots of good reasons to be really good at identifying tree systems. So then I get people proposing tree systems like topic, article, comment. Okay, it's going from general to specific, right, Sophia? No. This is not a tree system, okay? Or I'll get neighborhood, house, and room as a tree system. Nope. No. Or company, team, and employee. Okay, these are just going from bigger to smaller. An article is not a more specific version of a topic, and a comment is not a more specific version of an article. A house is not a more specific neighborhood, and a team is not really a more specific company. Not quite. It's a little bit of a stretch to think about it that way. And I've struggled with teaching this. I've struggled with kind of describing like, wait, why are these not tree systems? And I get into like, well, the data doesn't really, you don't need that data flow that you need in a tree system. And the eyebrow furrowing quotient goes up, and I confuse people. So recently, Richard Gower asked, and he said he's also, I'm giving credit to Richard Gower, and Richard Gower is giving credit to Alex Davidson. These are two amazing OUX mentors. So I will directly quote Richard saying, I'm thinking that in a tree system, all of the objects can almost be called the same thing. Yes. Okay. That is the key. Let me explain. Okay. So while neighborhood, house, and room, not a tree system, what is a tree system? Another example of a tree system, using just the house example, you could have something like house type, which would be, instances might be classic ranch, mid-century, or Victorian living. And then you could have a branch of your tree system. So that would be the root of your tree system. Then you could have a branch of your tree system as house floor plan. So that's the classic ranch 3-bedroom or the classic ranch 4-bedroom. And then you could have the fruit, which is the actual house. That is 123 Flower Street, which is a classic ranch 3-bedroom. Okay, now this is very important to separate these out and be very clear if are we talking about a house type, a house floor plan, or a house? Okay, because their structure is different. So those are 3 different objects. Okay, their structure is different, their instances are different. Instance of a house type being classic ranch, instance of a house floor plan being classic ranch 3-bedroom, and instance of a house being 123 Flower Street. Okay, are you staying with me? Hope so. Okay. This would help a lot if you read that tree system article. If you haven't read the tree system article, you might want to stop and go read that and then come back. Anyways, so even though this is so important for us to be really clear on house type versus house floor plan versus house, in colloquial speaking, in conversation, very likely the same exact word can be used, which is house. All right. So your clients even, or your stakeholders might be using house interchangeably for all of those. Okay. Now it's our job. It's part of our job to really listen up and start realizing, wait a second. When you said house, you were referring to an actual address that like has people living in it and has leases out on it and can, actually has a roof repair that is needed. And when you said house, you were actually talking about a floor plan, right? That it needs to be edited or something like that. Okay, that is still this floor plan that's still in draft mode that needs to be approved or something. And when you said house over here, you actually meant like kind of like an overall design schema, like mid-century modern. All right. So, and then it's our job to parse these out. Okay. And it can be really difficult in the beginning. So in that article, I used the example of movie at a theater, and the showtime. So the root being movie, The Little Mermaid, the branch being movie at a theater, The Little Mermaid at Mountain Cinemas, and showtime being The Little Mermaid at Mountain Cinemas this Friday at 8 p.m. Okay, so we need to, because again, the structure is very different. And one thing that I called out in that tree system article is permissions on those are very different. Who can edit the movie, like actually change the movie poster, versus who can say cancel a showtime or something like that. Probably very different roles. All right, but in common vernacular, we might be using the word movie for all of these, all right? So when you're doing user interviews, when you're talking to your stakeholders, oh my gosh, maybe even when you're talking to your developers, all these and other designers, all these words are being used interchangeably. And even like if I think about it, when I say, I don't say I'm going to a showtime. I say I'm going to a movie, right? Even though technically we cannot actually ever go to a movie. We can only go to a showtime, all right? So what is said is actually maybe not what technically actually is. Okay. So this came up when I was working with Autodesk. We had one workshop where we had, oh my gosh, in this sprint, we had so many tree systems. And I'll just give one example. We had machine type, which was something like laser cutter. And then we had machine, which was like, for example, the GE laser cutter 5000. And then we had the machine actual, which was a specific GE laser cutter 5000 that could be broken, that could be occupied, right? And so this was really tough because in the beginning, it was all just machine. So we had, I think it was like the middle of day 2 where we really started figuring out like, oh, these are actually 3 different things. And we need to say, does an employee, where do the permissions go? right? Does an employee get approved to work on a laser cutter? And once they get approved to work on a laser cutter, like they're approved to work on any of the laser cutters. Do they get approved to work on the GE Laser Cutter 5000? Or do they even get approved for a specific GE Laser Cutter 5000? Like, you can work on this one, but you can't work on that one. I don't know, but I need to figure that out. I need to ask those questions. All right, so there are these three very similar things, so similar that colloquially they could actually all be called the same thing, but they're actually different things. And I need to think about the permissions of each of these individual objects. So from an object mapping standpoint, from even like a design technical standpoint, it's so important to separate these out. And so this goes back to this idea of like, yes, there's how users talk about a thing, and we need to understand that. How our clients talk about things, how the business talks about things, how the users talk about things, and just everyday language. And then honor the fact that as professionals dealing with this stuff, we likely need a higher level of specificity when we talk about these things. We need to be really hyper specific, especially when we're designing complicated things. So to come back, so your new rule of thumb, when you're thinking about a tree system, you can even look at, is a word being used interchangeably a lot that actually feels like separate things? That is a good sign that you are looking at a tree system. And I will shout out to Shadi L, who she actually asked the question, is this a pattern that you see? I'll actually quote her, that when you're in discovery and you keep seeing a word repeated in interviews and briefs, and you're workshopping with a company and you hear employees using the same word and wondering if they are all talking about the same thing, this could be a moment to take note. Is it possible that a tree system is needed to be explored here? Yes, exactly. That is sort of like subconsciously what I've been doing. And now we can be more conscious about it to say, ooh, there's a word that's being used interchangeably. Is this just different levels of specificity that are being talked about? And which ones do we need to account for in our digital system? Okay, so tree systems is something that we talk about during relationship requirements because we get into these hierarchy patterns, we get into inheritance, but tree systems are definitely something that as soon as you can start identifying them, go ahead and start identifying them. You don't need to wait till you get to the requirements round. I will often identify tree systems during noun foraging at the very beginning of the process. This is just when we teach it in the OAUX masterclass because it would be way too much to be teaching during discovery. All right, so I think that was a really juicy episode. Apologies for the I wanted my my Santa example to be nice and cheerful, but then we started talking about houses getting burned down, buildings getting burned down. Apologies for that too. I don't know why I can't use the word building, but hopefully it was clear enough. Hopefully it's helped and gets you excited about doing some nested object analysis. Again, if you are more excited about diving deeper into this, and if this is all right, Sophia, I feel like you're talking about something that's important, but I'm not quite understanding everything, and I want to understand it more. About you get yourself a little holiday present. Invest in yourself. OUX.com/masterclass. Enroll. Join us. Join us in the forum as well. We will be talking about this episode. You can join for free, forum.OUX.com, and just go to that OUX bulletin board, and there will be a post about this episode where you can ask additional questions there. We also have monthly Q&A in the forum. And then if you join the masterclass, you get 2 more Q&As a month. So if you're in the masterclass, you have 3 opportunities a month to ask me questions, which is very helpful. So I hope everybody is having a wonderful holiday season, and cheers. Happy OUXing. Thank you so much for listening. I truly hope you enjoyed this episode. Please visit objectorientux.com/podcast for show notes. Our soundtrack is Fighter by Ruby Vell, courtesy of Sugaroo Records. Happy OUXing!